Can the derivative be useful in finding a limit? The answer is yes. This is climb time, and in this video, we are going to look at L'Hopital's rule. All right, let's say we have this little problem right here. We will find the limit as x approaches 0 of x over x. Well, our first strategy in trying to find a limit is to just plug in. So if I do that, if I just plug in, I'm going to get 0 over 0. What is that? What is 0 over 0? And the answer is it's an indeterminate. That's the answer. In fact, I have many of the indeterminate forms here. There might be more, but these are the ones that you'll see in calculus. And one of them is 0 over 0. 0 over 0 is called indeterminate. And I'm going to look at why that's true here by just looking at this problem right here, x over x. Well, we know that if I divide x over x, I'll get a similar function, which is the limit as x approaches 0 of 1. However, the limit as x approaches 0 of x over x is equal to the limit as x approaches 0 of 1. These two have the same limits, and the answer is 1. The limit as x approaches 0 of 1 is 1. So the limit as x approaches 0 of x over x is equal to the limit as x approaches 0 of 1, which is equal to 1. However, x over x is not equal to 1. They are not the same function. If I were to graph x over x, it would look something like this. I would have a hole at 0, and then it would go this way, and it'd go this way, and they'd go on forever. So it looks very similar to 1, y equals 1, but it's not exactly the same thing. There is one difference. The one difference is you cannot plug in 0 into the original function. If you plug in 0 to the original function, you'll get a 0 in the denominator, and that's a no-no. And so it's got a hole at x equals 0. So x over x is not the exact same thing as 1, at least not for all x. However, the limits are the same because as you approach 0 from left and you approach 0 from the right, the y value will approach 1. So their limits are equal. And that's something we've learned how to do before. I could also take the limit as x approaches infinity of x over x. If I did that, again, the first approach is just plug in. And if I plug in infinity over infinity, that's a problem. I get indeterminate. So whether I am plugging in infinity or plugging in 0, in either case, I get indeterminate, and I need some other technique to figure out what the limit actually is. And one technique is to actually try to simplify the fraction and see if by canceling out products, we can get something that's simpler. And one thing we know is that the limits are equal, even though the functions themselves are not equal. But what I want to point out, and I'll go ahead and write that in so that we can see that this is indeterminate, and this is also indeterminate. Okay, indeterminate. What I want to point out is what happens if I change it slightly, and instead of saying the limit as x approaches 0 of x over x, I now say 2x over x. Okay, if I plug in directly, I will get 0 over 0, which is indeterminate. Okay, so 2x over x gives me indeterminate. X over x gives me indeterminate, and that's when x approaches 0. So I get indeterminate there, I get indeterminate here. However, the limits don't come out to be the same thing. The limit in this case will come out to be 2. The limit as x approaches 0 of 2x over x is going to equal the limit as x approaches 0 of 2, which is equal to 2. So in this case, it's 2. In this case, it's 1. So they come out to two different things, but when I plug in initially, I get indeterminate. So indeterminate is basically means it can be more than one thing. So you can see in this case, 0 over 0 came out to be 1. In this case, 0 over 0 came out to be 2. So if it doesn't come out to be one value, it is indeterminate. And so the same thing is true if we got infinity over infinity or 0 over 0. So here are different forms for indeterminate. 0 over 0 is if when taking a limit, you get 0 over 0. That's considered indeterminate. If when taking a limit, you get either a positive infinity over positive infinity or positive infinity over negative infinity or negative infinity or negative infinity. So any combination of positive, negative, infinity over infinity, that comes out to be indeterminate, which means the actual limit can be more than one thing. If you get plus or minus infinity times 0, same thing. Infinity minus infinity, same thing. Less common, but still come up is 1 raised to infinity, 0 raised to 0, and infinity raised to 0. All of these are considered indeterminate. And what's interesting about these down here is that if I take 1 and multiply by itself, it always comes out to be 1. 1 times 1 is 1. 1 times 1 times 1 times 1 is 1. 1 raised to any finite exponent will always come out to be 1. But as soon as the exponent becomes infinite, so I multiply 1 by itself an infinite number of times, now the answer is not known. Now it's indeterminate. Now the answer, when you're taking limits, is when you're taking limits, now it could come out to be more than one thing. And that's the idea behind indeterminate. 0 to 0, same thing. Anything raised to 0 is normally 1, but not if the base is 0 or the base is infinity. So 0 infinity do weird things when raised to the 0 power. So these are indeterminate forms. And you can see in this case over here that when we got that indeterminate form 0 over 0 and we got the indeterminate form 0 over 0, the limits actually came out to be two different answers, 1 and 2. Now, 1 and 2 are not the only answers I can get. When I'm getting the indeterminate of 0 over 0, I can get pretty much any answer I want out of 0 over 0. So I could change 2x over x to 3x over x or 4x over x or 5x over x. I can get any integer that way, but you can imagine any other possibility as well. So you can pretty much, any limit can come out of initially an indeterminate form. So we need other methods. And one method we already know, which we can see right here, and that is just reducing the fraction. And then the limits come out to be the same when you reduce a fraction. By the way, and I'll say it again because it's worth repeating, 2x over x is not the same function as 2. They are not the same because they're not defined the same for all x values. However, their limits are the same. So that's why we can reduce when we're trying to find limits. Well, L'Hopital's rule tells us this, that if we have a fraction, an f of x over g of x, so if we have the limit as x approaches any a, really, it can also be infinity, of f of x over g of x, and if it comes out to be an indeterminate form, indeterminate. If that happens, if the limit as x approaches, and a could be infinity too, by the way, f of x over g of x comes out to be indeterminate, so it takes on one of these forms down here, then we can actually take the derivative. So limit as x approaches a of f of x over g of x is going to be equal to the limit as x approaches a of f prime of x over g prime of x. So when I say take derivative, I don't mean take the derivative of the whole thing, because if we're taking the derivative of the whole thing, then it would be a quotient rule. But we're not taking the derivative of the whole thing. We're taking the derivative of the numerator. So the derivative of the numerator f of x would be f prime of x. And we take the derivative of the denominator, g of x, will become g prime of x. And we take the limit after we find the derivative of the numerator and derivative denominator first. So what this tells you is in order to use L'Hopital's rule, you do need a fraction. So even if you get one of these indeterminate forms down here, you got to figure out a way to turn it into a fraction so that you can apply L'Hopital's rule. And so once you turn it into a fraction, once you turn it into a fraction, you take the limit. If the limit originally was an indeterminate form, then after you turn it into a fraction, it should also be an indeterminate form. Then you can take the derivative of the numerator and the denominator separately, and then take the limit again, and those two limits will be equal. Just like these two limits are equal. And that doesn't mean 2x over x is equal to 2. They're not. In the same way, f of x over g of x is not equal to f prime of x over g prime of x. They're not. Well, in some cases they might be, but generally they're not. But their limits are equal, but only if originally it comes out to be indeterminate. So we can see that this process works as well for our example over here. So if we took the limit as x approaches 0 of x over x, well, that comes out to be indeterminate. But if I take the derivative of the numerator and the derivative of the denominator separately, I would get 1 over 1 which is 1. And the limit as x approaches 0 of 1 is 1. Same thing with the 2x over x. So if I took the derivative of the numerator, I'd get 2. I take the derivative of the denominator, I get 1. 2 over 1 is 2. And so the limit as x approaches 2 is 2. And it would also work for infinity. As x approaches infinity, I would have infinity over infinity, take the derivative of the numerator, take the derivative of the denominator separately, and take the limit again. And you could see that also works. So this is one more strategy in finding limits.